Hello students, let us start the third conductance derivation. The third one is feedback conductance Gb-C. Last video I explained two conductances, transconductance Gm and the input conductance Gb-C. Now this is feedback conductance. Remember, we are deriving all these conductances in terms of H parameters. Okay, so H parameter model is at low frequencies. That is the reason along with the hybrid pi that is for high frequencies, you have to draw this hybrid pi at low frequencies also. By taking all these three circuits, we have to derive the conductances, various conductances. Okay, so now let us start this conductance. To start this conductance, first you have to go for the concept, the reverse voltage gain. The reverse voltage gain in terms of H parameter model is HRE. Okay, see this is the reverse voltage gain, HRE. Okay, HRE is the reverse voltage gain means in the H parameter model, this is your VB and this is VC. Here the HRE is reverse voltage gain means input by output, input voltage by output voltage. Okay, so here if you take this hybrid pi at low frequencies, see what is the reverse voltage gain HRE as this circuit and this circuit. This circuit and this circuit both are at low frequencies of CE, but the models are different, that's all. Though the models are different, the reverse voltage gains are same for the H parameter model and its hybrid pi model. Why? Because the two are at low frequencies. Okay. So now, what is the reverse voltage gain HRE for this hybrid pi at low frequencies? What is the input voltage? Input voltage is this VB-C. So VB-C divided by, what is the output voltage? VC. Okay. So now, let us take this HRE, that is VB-E by VC. What is VB-C? VB-C is the voltage across RB-C. What is that? That is, what is the current through RB-C? The current through RB-E is IB. This is the current IB. So it is VB-C is nothing but IB into RB-C divided by, what is VC? VC is the voltage across collector and emitter. As this is the parallel circuit, even you can take VC here also. This as the voltage VC. So now this voltage VC is nothing but voltage across the combination RB-C and RB-C. How is your RB-C? Your RB-C is like this. Your RB-E is like this. Okay. The voltage here is nothing but your VC. Means voltage, the sum of voltages across RB-C and RB-E is nothing but VC. From the input side, what is the current coming to this? The current coming to this is IB. Okay, let us take this, no problem, RBB dash. But the current is IB. Okay, the same current. So totally what is the voltage? So totally what is IB is flowing. IB is the only current which is flowing through RB-C and RB-C. So that is the reason what is VCE? VCE is nothing but IB of RB-C plus RB-E. Okay. So cancel your IB. So HRE into RB-C plus RB-E is equal to RB-E. Implies RB-E take common 1 minus HRE. You just take HRE into RB-E to this side and take RB-E common. So RB-E of 1 minus HRE is equal to HRE into RB-C. We know the reverse voltage gain is very less. HRE is very less than 1. Reverse voltage gain is less than 1, but the forward voltage gain means the voltage gain, simply call it as voltage gain. Voltage gain is very high. but the reverse voltage gain is very less. So that is the reason compared to 1. So it implies RB dash E is equal to, as HRE is less than 1, 1 minus HRE is approximately equal to 1. So RB dash E is equal to HRE into RB dash C. Implies your RB dash C is equal to RB dash E by HRE. What is your conductance? The conductance is GB dash C. What is GB dash C? GB dash C is nothing but 1 by RB dash C. It implies GB dash C is equal to 1 by RB dash C means HRE by RB dash E. Here you have 1 by RB dash E. So that is nothing but HRE into GB dash E. Okay, so this is the formula of the feedback conductance GB dash C. So now we'll move to the next conductance, output conductance GCE. Using H parameter model, the output conductance, what is the output conductance in the case of H parameter model? HOE. See this is HOE. HOE is output current by output voltage. Now we'll take hybrid pi model. From the hybrid pi model, I'll write IC, output current. So what is IC here? See this IC from the collector. This is IC, this one, and this one. It has 3 parts totally. What is the first one? IC is equal to, I'll take RCE value, VCE by RCE. Means the current through RCE is the voltage by resistance plus another is there, that is GMVB dash E. Let us assume the current flowing through this input side as I1 plus I1. So this is the current flowing through the input side. When you are finding the output conductance of the H parameter model, according to the definition, you have to make input circuit open. That is, you have to make IB is equal to 0. When IB is 0, what is the current through this? The current through this is this I1 only. The current through this total is your I1. So what is I1? And what is the voltage across these terminals? When your IB is 0, your RB dash C and RB dash E seems to be in series. Because from this side there is no current. And what is the voltage across these two terminals? It is nothing but VCE because all this is parallel. So what is VCE now? VCE is nothing but the I1 into the two resistors seems to be in parallel. So I1 into RB dash C plus RB dash E. Okay. So what is I1? I1 is VCE by RB dash C plus RB dash E. Just substitute an IC expression. Therefore, IC is equal to VCE by RC plus GMVB dash E plus VCE by RB dash C plus RB dash E. And when IB is equal to 0, when IB is 0, what is VB dash E? It's nothing but voltage across RB dash E. What is the current through RB dash E? I1. So it implies when IB is 0, VB dash E is I1 into RB dash E. Substitute this also here. So it totally gives IC is equal to VCE by RCE plus GM VB dash E. In the place of VB dash E, substitute I1 into RB dash E. We have already I1. So directly substitute I1 VCE by RB dash C plus RB dash E into RB dash E plus VCE by RB dash C plus RB dash E. Now divide the entire equation by VCE. Now you'll get IC by VCE. VCE gets cancelled, that is 1 by RCE, plus here also VCE gets cancelled. So GM RB dash E by RB dash C plus RB dash E plus 1 by RB dash C plus RB dash E. That implies, I am explaining here, is IC by VCE from the H parameter model, HOE. HOE is equal to 1 by RCE plus, what is GM RB dash E? You have a relation RB dash E is equal to H of E by GM. So your GM is H of E by RB dash E. Therefore, your GM into RB dash E can be written as, you can verify the input conductance GB dash E. So GM into RB dash E can be written as H of E. So your H of E divided by RB dash plus RB dash E plus 1 by RB dash C plus RB dash E. So that is equal to 1 by RCE plus 1 plus H of E divided by, take just LCM RB dash C plus RB dash E. That is equal to 1 by RCE. You all know H of E is very high. It is very high. So when H of E is very high, 1 can be neglected when compared to H of E. So it is H of E by RB dash C plus RB dash E. As RB dash C is far greater than RB dash E, we know RB dash C is the reverse resistance which is in terms of mega ohms, and RB dash E is the forward resistance which is in terms of ohms. So RB dash C is greater than RB dash E. So you can write HOE as, what is 1 by RCE is nothing but GCE plus H of E by, is neglect your RB dash E, so it becomes RB dash C. So that is equal to GCE plus 1 by RB dash C is nothing but GB dash C. So GB dash C into H of E. So totally the output conductance GCE is equal to HOE minus GB dash C into H of E. Okay. So I think you understand. Now the last one is, it is not conductance actually, it is simply the base spreading resistance RBB dash. From the H parameter model, input resistance by making output short. Output short means, here output short means you have to make VC is equal to 0. When you make VC is equal to 0, what is the input impedance for this? See here from the H parameter model, what is the input impedance? Ri is nothing but, the only resistance in the input circuit is HIE. The same way, from hybrid pi at low frequencies from this circuit, when VC is equal to 0, when you make VC is equal to 0, what is the input resistance? The input resistance Ri is nothing but, there are 3 resistors in the input side, RBB dash and the parallel combination RB dash C and RB dash E. So the RBB dash is in series with the parallel combination of RB dash C and RB dash E. So Ri is RBB dash plus RB dash C in parallel with RB dash E. Okay, as these two are the input resistance of the amplifier at low frequencies, you can make both equal. HIE is RBB dash plus, see the parallel combination, RB dash C is very high and this is very low. A very high value of resistance in parallel with very low value of resistance, you know, it gives low value. So it is RB dash E. So totally your base spreading resistance RBB dash is HIE minus RB dash E. That is nothing but HIE minus, yes, RB dash E is HFE by GM, or you can write another form as HIE minus GM is IC by VT, you know, HFE into VT by IC. Okay, these are all the equations for RBB dash. So this is the concept of determination of hybrid by conductances. We totally derived 5 parameters, 4 conductances and 1 base spreading resistance. Okay. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.